Hi friends, let's work on some more special cases today. So if we have to find out the integral of dx upon x squared plus a squared, it turns out to be 1 upon a tan inverse x by a. How does that happen? We know that integral of 1 upon 1 plus x squared is equal to tan inverse x, right? Now plus c. Now, if you have x squared plus a squared, instead of 1, basically, if you have a squared there, then how will it function? So what you can do here is, again, the substitution will be of the sort that, conversion would be tan secant square and tan. So if you take dx as a tan theta, then if you take x as a tan theta, then your dx turns into a secant square theta d theta. Okay. So your conversion of the integral 1 upon 1 upon x squared plus a squared dx would turn into a secant square a secant square theta d theta in the numerator and a square tan square theta plus a square in the denominator. A square could come out common in the denominator and cancel out with one of the a's. So you will be left with 1 upon a in total. And then you have secant square upon tan square plus 1. Now tan square plus 1 essentially is secant square, right? Tan square plus 1 is secant square. So tan square plus 1 is secant square. So this becomes simply, if you this cancels out with this, since they both are equal, because tan square theta plus 1 is actually equal to secant square theta, that is secant square theta minus tan square theta is equal to 1, using that identity. And hence it's just the integral of 1 upon a d theta, which will be 1 upon a theta plus c, and theta is nothing. Now you can get that you've taken x as tan theta, a times tan theta. So that means x upon a is equal to tan theta. That means theta is equal to tan inverse x by a. And hence that is the correct answer. Hence that is the correct answer. Next question. Next special case. This is again with log. Integral, now we were working on currently integral of x square plus a square, 1 upon x square plus a square, and that turned out to be in terms of um, tan inverse. Now we've already seen the integral of 1 upon x square minus a square, which turns out to be something in terms of log. This time we have 1 upon square root of x square minus a square. Let's see how we can work it out. So let's here take x as, again, a secant theta. This time let's take x as a secant theta. Dx will become a secant theta tan theta d theta. Okay. Now, when you are integrating 1 upon square root of x square minus a square root in square root. So you are basically integrating a secant theta tan theta d theta is your numerator upon square root of a square secant square theta minus a square. So a square can come out common and it comes out of the root. What you have is square root of secant square theta minus 1 in the denominator and secant theta tan theta in the numerator. Secant square minus 1. Since secant square minus 1, secant square is actually tan square plus 1. Secant square is actually tan square plus 1. So if you substitute it there, you will just get, this is nothing but tan square theta. It is nothing but tan square theta. So you have a cancels. A cancels. You just have secant theta tan theta upon square root of tan square theta. Now you know that the derivative In fact, no, in fact, this just cancels. So you are only left with secant theta, secant theta. So the integral of secant theta d theta, now we can figure it out. The integral of secant theta d theta is log of secant x plus tan x plus c. Log of secant x plus tan x plus c. And I've just given you a brief recall here how you get it. You multiply and divide by secant x plus tan x. We've done this before, actually. We've done this before. This is just to recall. And then with substitution, you get log of mod secant x plus tan x plus c. Now, which means that what do you have? The answer to the integral that you've been looking for, 1 upon square root of x square minus a square dx. That's equal to log of secant theta plus tan theta mod plus c. Now, you know what x is. We have to write it in terms of x, not in terms of theta. Now, our assumption was that x is equal to a secant theta. So that means secant theta is x by a. So we have log of x by a here. Plus, using the identity that tan square is, tan square is secant square minus 1. Using that, you get square root of x square by a square, that's secant square minus 1. So log of this plus c. Now simplify it to some extent, if possible. A could be a common denominator here, which can come out also. A could be a common denominator, which can come out in the sense it's log, it's inside log in the denominator, so it can be taken as minus. Now log a is nothing but it's a constant, because a is a constant, so log a is a constant. So essentially your integral turns into log of x mod of x plus square root of x square minus a square plus some constant here, constant plus some constant here. Now this constant includes a, but for us it's a constant only. So the integral, you can say, is this. And again, try to match always when you're integrating, at the end of the question, just try to understand if the integral of a given function is turning out to be this, that means what is it talking about as a function, what it is talking about. The relation between derivative and integral, try to relate that. Next question, next special case is the case of square root of a square minus x square in the denominator. So integral of dx upon square root of a square minus x square in the denominator. Okay. So it will turn out to be sine inverse x by a plus c. Let's see how. You consider 1 upon square root of a square minus x square and consider x as a sine theta. If you consider x as a sine theta, automatically dx turns out to be a cos theta d theta. Let's make this substitution. So this becomes the integral, required integral I becomes integral of a cos theta d theta upon square root of a square minus a square sine square theta. Now a square, could be taken common. So a comes out, cancels with the a in the numerator. So you have cos theta upon square root of 1 minus sine square theta, which is cos theta only. So this cancels. The only thing that remains is d theta. So integral d theta is just theta. So theta plus c is your answer, and theta is sine inverse x by a. That's because I have taken x as sine theta. So x by a is sine theta, and sine inverse x by a is theta. Another special case is where you take integral of dx upon square root of x square plus a square. X square plus a square in the square root this time. Again, the answer will be in log of x plus square root of x square plus a square plus c, of course, plus c. So how do we get it? Again, the substitution you will take here is, since it's x squared plus a squared, the substitution you will take is, see, because of the identities are such, identities are such, the secant and tan identity, and that's how you realize that in squares, when you have x squared plus a squared, x squared minus a squared, what should I use? Should I use sine, cos, or secant and tan? So it depends, really depends on the plus, minus, and all. So what do you have here is, if you take x as a tan theta, your dx will be a secant square theta d theta, right? Let's make the substitution. Clearly, just like in the previous case, you'll have this a secant square theta d theta upon square root of a square tan square theta plus a square. So a comes common, it can cancel out. You have secant square theta upon tan square theta plus 1 in the square root, which is nothing but secant. So one secant cancels and you are left out with integral secant theta d theta again, which is log of secant theta plus tan theta in modulus plus c. Now you can substitute the value back. So it will be log of x by a. Exactly the same substitution is there, okay? Plus square root of x square upon a square plus 1. So hence you can take the LCM and this goes as minus a, and you can combine it with the constant. So your answer is log mod x plus square root of x square plus a square plus c. Next, let's work on finding the integrals of the form 1 upon ax squared plus bx plus c. So if you have this kind of a form, how do you factorize and how do you simplify this situation if the integral is of this sort? So what you can do is just consider ax squared plus bx plus c, and let's take a common. If you take a common, you remember we've done in quadratic how you break it. So you can create whole square here. So x plus b upon 2a whole square. For that, you have added and subtracted something. So that comes out here. So you have a and this multiplied by this expression. One is whole square and one is c by a minus b square upon 4a square. Now in here, if you put x plus b upon 2a as t. If you put x plus b upon 2a as t, dx will be equal to dt. Right? And this expression will look like, very simplified, because this becomes just t square, right? Now, if you write down c by a minus b square upon 4a square as sum plus minus k square, writing c by a minus b square upon 4a square as sum plus minus k square. This expression will look like 1 upon a common, and with that you have dt upon t square plus minus k square. Now, dt upon plus t square was this expression. Now this expression becomes t square, and let this be sum plus minus k square. It will depend on the sign of ca minus b square upon 4a square. The sign will depend. It will be dependent on this, okay? Now understand it through an example. So if you have integral of dx upon x square minus 6x plus 13, what we will do? We will factorize it. We will create square. So you can create a whole square with x square minus 6x with adding and subtracting 3 square. So adding and subtracting 3 square, I'll get x minus 3 whole square, because you have minus 6x here. So you will have x minus 3 whole square could be constructed. So x minus 3 whole square, and you'll be left out with 13 minus 3 square. So that is 9. So you'll be left out with 4, right? You'll be left out with 4. So this becomes a dx upon x minus 3 whole square plus 2 square. X minus 3 whole square plus 2 square. Now, integrating this is very simple because we've done all these special cases. We've done the case of dx upon x square plus a square. So it will be something of that sort. Now you put x minus 3 because you don't have simply x square. You have x minus 3 square. So put x minus 3 as t. So you will have dx equal to dt. Nothing happens to your integral as such, no much change. And your integral turns into dt upon t square plus 2 square, which is the form 1 upon x square plus a square, and you get the answer as a is your 2. So it'll be 1 upon 2 outside and tan inverse t by 2. T by 2, this I've t by 2 x by a, right? So t by 2, and then you convert it. You have an answer in terms of t, get the answer in terms of x. So half tan inverse x minus 3 upon 2 plus c. Okay. So that's basically, that's how you use it. So whenever you have ax square plus bx plus c, this is how you should probably proceed. So if you have dx upon 3x square plus 13x minus 10, you can take 3 common and then create whole squares. So 3 common, x square plus 13 upon 3x minus 10 by 3. So you can create whole square here, x plus 13 by 6 whole square minus 17 by 6 whole square. This you've completed the squares, nothing else, because you have 13. See, completing the squares is based on this. If this is your 2 ax, okay, product of the two x square plus a square, you're looking at x square x minus a whole square or x plus a whole square. So this is plus minus whatever it is 2ax, then accordingly you create your, you know, the second the number that you have to add and subtract square. So this is what you get here. And again, what will you do? You will put x plus 13 by 6 as t, dx equal to dt. Not much of a change there, dx equal to dt. So your I integral becomes 1 upon 3 is out here common, and dt upon t square minus 17 by 6 whole square. This is your k. So that's what I meant by plus minus k square. It depends on what are you left out with. Okay, is it plus or is it minus? Then what will happen? So this will be equal to 1 upon 3 into 2 into 17 by 6 log, because this is of the form now. This is of the form integral 1 upon x square minus a square. Remember, so you get an answer which is, you know, x minus a upon x plus a after creating, remember we created and then we got this answer. So 1 upon 3 is outside, then you have 2, a of this is 17 by 6, so 2a, 1 upon 2a log x minus a upon x plus a. And then in place of t, you can write down what t is. It is x plus 13 by 6, so just put it there and your answer will be like this in terms of x. This is what you get in terms of x, okay? This is what you will get in terms of x. You can even further simplify as I've done here. You can even simplify because you had some common, you know, you could divide by 2. So dividing by 2 throughout, you will get this 3x minus 2 upon 3x plus 15. And then I've taken 3 common here. I've taken 3 common here because in log, when you have a product, then it becomes just plus. So I've taken it to this side, and this entire thing could be, it's just a constant because log 1 by 3 is a constant. So it's the most simplified form of this integral will be 1 upon 17 log 3x minus 2 upon x plus 5 modulus plus c, the constant.